Now, we can use residuals to check the strength of a model. And what I mean by residuals, you can think of residuals as the error. So when you have unless you have perfect data, a line is not going to be able to go through every single point. So there's always going to be a little bit of error between the actual data points and the line. That variation, that difference between the actual y value versus your predicted y value, is called the residual. So for the example on the screen, I'm using the residual for this data point right here in the upper left. That y value is the actual y value. But if I go straight up or straight down to the line, and where I touch the line by going straight up or straight down, that's the predicted y value. This difference between actual and predicted is what's called the error, or residual. And the residual is the actual value minus the predicted value. So, for instance, suppose for my cricket data, I'm using the equation that the temperature is 45.8 plus 0.738 times the number of chirps. And I want to predict the temperature if there were 46 chirps in 15 seconds. Well, using my calculator, 45.8 plus 0.738 times 46 gives me a predicted value of 79.748 degrees. That's the prediction. Based on the equation, that's what I'm predicting the temperature to be. Now, if I want to find the residual, let's assume that the actual temperature was 78.5. So I'd go actual 78.5 minus 79.748 or 75 if you want. Well, that's not right. Try that again. I take 78.5 minus what I said. My prediction was 79.748. Details, right? Yeah, negative 1.248. So negative, you're going to end up with a negative residual when the predicted is higher than the actual. So negative 1.248 is saying that the actual temperature was about 1.248 degrees less than predicted. So again, to make the prediction, you take the equation and replace the x value, in this case the chirps, with this 46. That comes out to be about 79.75 degrees. Find the residual if the actual temperature is 78.5. You take the actual minus predicted. So the actual value is 78.5. I subtract off 79.75. I get negative 1.25. That tells me the actual temperature is 1.25 degrees cooler than I would have predicted. So my prediction was high by about 1.25 degrees. If I went with a different equation, 30 plus 1.192, well, again, if I'm using this equation, I want to predict if the degree temperature, if there are 25 chirps per 15 seconds, I would start off 30 plus 1.192 times 25 chirps for every 15 seconds. And that comes out to be a temperature of about 59.8 degrees. Now, if the actual temperature was 63, then I'd go 63 minus that 59.8. And my residual in this case is 3.2. It's positive. That tells me the actual temperature was 3.2 degrees higher than I predicted. So we use the equation. We get 59.8 degrees. The residual, actual minus predicted. The actual value we're told is 63. Subtract the 59.8. And I get 3.2.